Good afternoon and welcome to the AI Integration Center podcast. My name is Lieutenant Colonel David Paddock. I'm the Senior Capability Developer at our Army-wide integration section here at AI2C. And we're going to explore how AI can help make the Army make better decisions faster, really achieve that decision dominance. I'm going to be the host for this series, and in every episode, I'm going to be joined by a variety of subject matter experts to tackle one particular overarching question, and we'll build on this series as we go through. Today, we're looking to address what is AI and what isn't AI. We know it's not science fiction. This is software, this is science, and it's already improving a variety of things that we do within the military, from logistics to maintenance to intelligence and operations. With this 10 episode series, we're going to cut through a lot of the hype and the buzzwords, and we're going to talk honestly about what AI is, how it works, and most importantly, how we're integrating it to responsibly support the warfighter and maintain operational overmatch with our adversaries. Joining me today is an officer with a background in data analytics and mathematics who's going to help us strip away the buzzwords and get to some real definitions. Why don't we go ahead and start off with some introductions?
Well, yeah, thank you, sir. I am Captain Thomas Canchola. My background is mathematics and machine learning. I have been at AI2C, the Army's premier AI integration center, for the last 2 years. And prior to that, I've gotten a degree in a data science related field from CMU and a degree in economics from Purdue University.
So the Army is building our AI expertise organically. So we're taking officers with strong technical backgrounds, such as yourself, with a degree in mathematics, and we're building our own cohort of AI experts. So in addition to coming in with a strong academic background and the great education that you're getting, you're also bringing a certain depth of knowledge about the Army culture, how the operations process works, and what leaders are going to expect AI to do. Can you give us a little bit about your military background as well?
Yes, absolutely. So I commissioned as a signal officer coming from the ROTC program in UC Santa Barbara. I was the S6 OIC over in Okinawa prior to coming to AI2C.
So let's go ahead and dive right into the big topic and establish some of these definitions. What is artificial intelligence? We're not talking science fiction here. This is the technology that we're already using in our formations. Can you tell me what AI is?
Yeah, that's an excellent question. AI means a lot of things to a lot of different people. To some people, it's kind of just like anything that is automation. To others, it's a very narrow scoped thing, such as large language models or computer vision, those types of things. I think the best way to characterize where we are with AI and what it is I'd liken it back to where computers were in the early 90s and early 2000s, where computers and like a dot-com bubble were like exploding. Everyone wanted computers. They were new hotness. They were supposed to increase productivity across the board. Everything about AI was happening back then. But back then, the reason why the dot-com bubble was a bubble was that people were trying to sprinkle a little bit of computer all over everything without having a specific plan for it. So what I would say is AI is currently kind of what computers were back then, which is something that has a lot of potential, but is currently something that needs a very, very specific scoped problem that you want to apply it towards to make it actually useful.
So, and that provides a lot of great context. You know, it's a technology that as it gets implemented is going to have some growing pains, we can assume. It's
Yeah.
probably going to have some busts, it's going to have some booms. As we work through some of these definitions, I hear a lot of different words flying around. I know everybody is familiar with ChatGPT and a large variety of these large language models that are out there. The Army has its own now with Gen AI, but I'm also hearing things like neural networks, generative AI, artificial general intelligence, agentic workflows. There's a lot going on out there. Can you provide me a little bit of a little bit of a better understanding about how these different terms relate to each other? I think there's some overlap, but I also think we get confusion, especially in the non-technical expert side, with really mean, and how do I employ it? Is this a thing I need, or is this just a hot buzzword that's going to have me investing in the wrong thing? And how do I avoid that?
Yeah, absolutely. Without going too deeply into the nuances of the different architectures and things that define them, I would say the thing that really ties all the different AI systems, like each different architecture together, is that it's generally statistics. So all of AI is just statistics done very quickly. People thought instead of just doing small scale statistics on a specific data set, they thought, okay, what if we make it so that the process of getting those statistical properties from the data set is kind of automated within the pipeline of generating it. And so where AI is used and kind of what it's useful for and all these different ones are anything that can be done using statistics. So you brought up large language models. So kind of how they work on a high level is they are a sentence prediction where it's trained on all of this data. So you take all of the sentences, posts, etc. on the internet, and you then train it so that it says, what is the statistical relationship between different words in different contexts and different sentences? And then when you give it a new prompt, it secretly is a story generating model. So you're then taking it and you're telling it, this is a story between a human and a helpful robot. It then gives the prompter the ability to write the story of words, sentence by sentence, on how to respond to it. And so I guess that was again, without going too deeply into it, the way that that's similar to other things. So computer vision was my main area of expertise. The way it works in that is if an object detecting model, for example, it's you give it a bunch of images of things that you want it to detect, and it tries to figure out statistical patterns between the objects that you've given it to then say, oh, this is a car. So like a car looks different from different angles. And so there's not an easily discernible pattern between a top-down view and a from the side view. But the hope and what machine learning is kind of effective at doing is taking those very kind of disparate things and figuring out that relationship where it can actually do those detections.
Man, that's a lot to unpack. That's a lot of great information. So I want to take back to what you really started off on. It's all statistics. So as anybody who's spent any time in the Army as a staff officer, you're going to become painfully familiar with Excel, right? I remember my days of having to go through and write macros so that we could use Excel more efficiently. And it sounds like AI is taking a lot of that work and is able to do the analysis without the front end work from the user. Is that correct?
Yes and no. I would say that LLMs are, again, what we're saying is that the statistics that they're looking for is in the patterns within the training data that it was given. So you give it all of the historic data of, say, like op-word writing, for example, all of your historic op-words, and then you say, hey, I need an op-word for this new task that's coming up. It will say, okay, generally speaking, these 5 words in the op order are going to change from this task to this task. So I'm going to put the new words in those spots that are most likely. What that doesn't do is look specifically at the ground truth or ways to make sure that what it's putting is correct. So there's definitely an art behind being able to leverage these tools to be effective, because even when they're wrong, they're very effective at sounding correct.
Well, and it seems like there's a risk. There's the risk of I read it and it says nothing, right? That's risk category 1 of it doesn't effectively communicate a message. And it seems like risk category 2, which is where we get into things like hallucinations, is it says something very convincingly that is objectively incorrect once you go into the source data for how it's deriving that. And can you explain to me a little bit about how we get into this hallucination process as we go through the statistical approach to it? I have this feeling that as we start dealing with artificial intelligence in military contexts, that particularly for things like writing an op order, how we train it matters, because we're not going to be able to use the same training data as is used for some of these commercial models that don't have to use the same amount of information, or that sometimes use words in entirely different contexts. And you're aware of this as a military officer. The military language is a little bit different, right? It's English with a little bit of seasoning on it, and we use words differently. So how do we deal with that aspect of training the AI in order to make it useful?
Yeah, so training it, there's two different sides to that, to answering that. One side is that there is academic research that's being done to kind of make the models more robust. So some approaches are you have the model that gives the answers, but you have a supervising model that takes those answers and then says, does this seem like it's kind of just lying to you, or is it actually trying to pull information, like trying to align those? That is something that's still being developed. So that I can't say too much about the effectiveness of doing something like that. As for curating the data itself, in an ideal world, these models, if you give them all possible combinations of, words, etc., that would happen in real life, then you ask it to generate something. It finds in its training set the exact time when that had happened in the training, and then pulls those exact words for you. That would be like the ideal case. So the only way that you can improve the data is to kind of approach having all data that you need. So from that standpoint, it's just, if it doesn't perform well, you then take the data that you generated of like, this is what it gave me, this is what it should have been, and then use that data to further the training. So you kind of just keep iteratively improving. That's kind of the realistic approach, which means I think, at least in the short term, we need to be very cognizant of making sure that the outputs are correct, doing the due diligence of double checking, fact checking, whatever the AI is actually saying. There was a study, I think, in 2025 about the effectiveness of AI on coding speed. Everyone predicted that adding AI assistance to developers would increase their efficiency. It was a study of, I believe, 19-ish competent developers, people with 10 plus years of experience. And it turned out they had roughly a 20% slower speed when they were allowed to use AI versus when they weren't allowed to. I would say that that study eliminates one and two maybe important things. One is that we're going to have to check the answers of AI until we get enough data to kind of eclipse that. The other one is those were all expert coders. I don't think there's an equivalent study with like non-expert coders. So it could just be that if you're at the beginning level to intermediate level, that AI is just going to completely improve your performance, at least on the coding side. And the reason why I think this is relevant is you mentioned all the jargon on military terminology. Coding is also a very specific type of language. And so coming into the military context, you can probably see the same type of impact, where those that are probably more proficient at it, if they were to use AI, will probably run into the case of having to make sure that they're checking it more, make sure that what it's saying is correct, versus where if they just wrote the order themselves, they might be faster. But when it comes to those junior officers being able to do it, it will give them a much stronger template to start with to then work off of that I think they might not otherwise.
Yeah, and that's really a great parallel when you talk about those differences in the language and the unique aspects between coders and the military lexicon and vocabulary. And I think that's a really interesting way to view that problem set.
Again, we're in the kind of wild west of this. I think my main statement with it all is that we should make sure that we have specific use cases in mind, because AI is just another tool on the tool belt. Not everything needs its own like website.
I think that that brings up some interesting points, and you really kind of stepped right up to it when you said that the the outputs created by these junior users are going to need and still require validation by more senior users. It sounds to me like what you're talking about really is either human in the loop or human on the loop
Mhm.
as kind of a factor that enables and ensures that there is a person that is still responsible for decisions. Can you talk to me a little bit about what the difference is between a human in the loop and a human on the loop, and how do we design and engineer the architecture for these models that ensures that we're maintaining that as a safeguard?
Yeah, so broadly speaking, human in the loop is during the decision making process, the human is actively involved. So, say it is a call for fire software, for example. So, a human in the loop solution would be if you have some kind of AI identify a target and then it sends to a human, hey, do you want to conduct a fire mission? And then the human has to hit accept, deny, etc. Human on the loop would be in that same situation. The AI identifies it and then sends it back, the fire mission back to something like the gun line saying, hey, I've identified this, please shoot at it. Whereas a human is just kind of observing it with the big red panic button of saying, oh, no, please don't do that. That is a bad target.
Well, it feels like where we put the human in the loop or where we put the human on the loop really matters, right?
Mhm.
I can say that I've got an artilleryman that's still going to be there to pull cord, but that may not be the right place to have the human in the loop, correct?
Yeah, absolutely. I think designing that is going to be an important and integral aspect of AI usage. I think it's one of those that you can't just say, "Oh yeah, we can just add AI to do this part." We have to really make sure we're focusing on how we're implementing it and if AI is the correct solution in the first place. So going back to like a geolocation standpoint, you could design AI to find the distance between you and that target using the relative sizes and the objects that you've detected in the pixel space, that kind of stuff. But geolocation is also done, you can use simple trigonometry to get a relatively accurate position. Just doing the triangle math of your height to the target, you can just calculate it. So some things can be done with AI, but the question is, are there non-AI solutions that have already been made? I think that's the first question. And then if there isn't a solution that's already made and AI can do it, where does AI fit into this pipeline where we can align the people to it so that it actually improves the workflow rather than adds more time? So, for example, the human in the loop perspective, if validating that target recognition, if it takes the human a really long time to orient themselves to what the AI is seeing and then identify it, it might just make sense for the human to be the one initially to just identify it if it would be faster for them to do that. So yeah, exactly what you said, where they're in it and making sure that it's all well thought out.
Well, and that really plays back to what you were talking about earlier, right? Like not every application needs an AI solution, but it seems like there's a trade-off as well. If I'm not using AI, I'm not getting the training data from using it as well, which means it's going to take me longer to adapt in the future. So there's no free lunch on this.
Mhm.
When you were talking about that human in the loop and the human on the loop, and it brought back, that concept of how do humans exercise judgment, right? This very ephemeral concept of what is judgment, how do we exercise judgment, right? It comes down to, what is consciousness, and you start trying to judge in on, what is good, what is bad. But are we making advances in seeing AI doing judgment, or is this just a human looking at AI and seeing the statistical patterns and trying to imbue it with something that we ourselves have because we want it to be there?
I mean, that's an excellent question. I think because AI is just like a broad application of statistics, given how complicated the decision making process tends to be, I am a little skeptical that we're close to getting AI capable of that in the near term, but not
So,
to preclude.
so we're not close to Skynet yet.
Not yet.
Not
Yeah.
yet. That's good. I don't need the Terminator walking around anytime soon. We hinted at it earlier, but I want to circle back to it where we talked about um, how you avoid the hallucinations, and part of that is providing good prompts. Are we moving closer to AI models that are able to, and I don't want to say that they're able to read your mind, but they're able to predict future movements or predict future thoughts or future demands in an automatic process?
Probably not. I mean, I think the closest we see that is like Microsoft Word, for example, has a like autocomplete function, for example. Things like that might be where we're currently at in that regard, where it's like, oh, they said they started their sentence this way. The only common sentence is finished this way, you know. So, but prediction of what people are going to do, I think there's just not enough data to really be able to draw conclusions. And even if there was, it might just be too noisy of a process.
Well, no, and that's great. And I think that brings back, to the bigger point of even as the AI progresses, there's still a role for that human creative element, even in military operations, to exercise those creative arts. If everything is based off of these statistics, invariably something will have happened before, but it becomes a commander's trick to figure out what options they want to take, what options they want to work to develop in order to move towards that in-state goal.
Yeah, I strongly agree with that. I think that's a good characterization where it's like these models are, I guess there's two separate types of models to talk about in that regard. There's the ones that take previous data and kind of best fit them. That's generally kind of more of the LLM side of things. Those are less effective at being creative. And so if you've seen the AI Google search things, if you ever Google search anything that is less common, it usually stumbles to provide good results. The other one is called reinforcement learning, the AlphaGo that solved Go, the chess algorithms like Stockfish. Those use synthetic data to train themselves. So they kind of set up a scenario and play the scenario, because in these settings, they're games usually, but just like iteratively do the scenario, and those can tend to generate more creative outputs. The issue is there's not really a good simulation environment for real life that a model could just repeatedly play in as a sandbox.
No, that makes a ton of sense. And when you talk about not having the resources, I know one of the things that we've talked about recently is the growth in some of these models, especially in the LLM space, which I think for most people is their first real interaction with what we'd consider artificial intelligence today. I certainly in my experience, and one of the interesting things to me at least is the ability of a lot of these large language models to take in more than just language. So I can go into an LLM and I can feed it in images and graphs and charts, and it's able to seemingly understand or contextualize in a language format what it is that I'm providing. And that's an interesting development, and it seems to be providing a lot more capacity for commanders who are or staff officers who are interfacing with AI on a regular basis. They're oftentimes dealing with a system that seems to combine a lot of these other information pieces. Do you think that as this field progresses that we're going to see increased specialization across the fields?
Yes and no. I think if you have basic knowledge of how AI works and kind of what to look for, when you have a new problem set where you're like, okay, this is solved with this specific AI, it's an exercise in, okay, well, let me look at the architecture. Let me look at how they're implementing these things. So I think it's a generalization rather than a specialization, mainly because it's also a very rapidly advancing field. So if you specialize too much, you might suddenly not have anything to work with.
No, and that's great. And that really circles back to where we started off our conversation, right? So when you return to the force, you're going to return not just with a narrow technical skill set, you're going to be value added largely because of your generalized knowledge about artificial intelligence and your ability to then apply everything you know out of context.
Yeah, absolutely. I think AI is usually just one of those things that kind of what I said earlier is you need a specific use case, but it's something that's being sold as something that you just like, oh yeah, let's sprinkle some AI here, there, everywhere, kind of trying to apply it universally. And to be able to best implement AI, we need people who can discern what is a good use case of AI and what isn't, which just requires people to have the knowledge, have the background in it, to be able to look at what's trying to be sold to the army and say, yes, this makes sense as a product, or no, this is something that we can do already in an easier way.
So you really kind of hit three different categories of education, right? There's the technical experts like yourself who are trained in artificial intelligence. There's the training that you've called out, which is on the acquisition side. How do we get acquisition professionals to understand what the need is? And then there's the user training, which are people like me and commanders in the operational force who aren't doing acquisition and aren't doing the hard coding, but we need to be able to interact with it and employ it effectively. Can you tell me more about, if you were to identify what the couple of high points are that are most important for the users who are employing these different AI models on a regular basis? What's important for them to know today as they're using it, and what's important for them to keep in their mind as considerations moving forward?
I would say because the models are statistics based, et cetera, so things don't always act in a very deterministic ways. But what you can do is use it a lot and then see what it gives you as output and do those checks, do those validations. I think that is the best way of learning how to use it. Being able to distinguish that is, I think, the main thing.
That takes a lot of experience to figure that out sometimes.
Exactly. So the best advice is you just use it, but use it as a very skeptical user all the time.
So you really hinted at something very important, right? What it's good for this purpose. So if I ask it a question about, to your earlier computer vision point, if I ask it a question to identify all of the cars in this picture and it does it correctly, consistently, I can trust it as far as identifying cars in pictures, but that doesn't mean that I can trust it for identifying helicopters in pictures. So really what we're talking about is developing what is essentially a form of context-bound trust, where we're looking at identifying how we trust it and then building up those different contexts throughout consistent use. And really what you're saying is the only way that you can develop that is by using it a whole lot on a regular basis in a variety of different contexts, and then having that human judgment in order to go back and figure out where it is that we're going to trust it and where it is that we're not going to trust it or not even employ it in the first place. Well, that's excellent. Well, we have covered a massive amount of information across a broad swath of artificial intelligence today. And really, I do appreciate your time today. We talked a lot about pattern recognition. You hit on some probabilities and a lot of statistics, but it's math, really, right? You're a math major. You are a hard science guy. This is not magic, and you have reassured me that this is not Skynet. So thank you for that one. But it's a force multiplier, something that is going to enable commanders to do the things they do with a better understanding of the data. But it's not a fortune-telling machine, and it's not going to replace the creativity that goes into the operational art for commanders. Well, thanks so much. I enjoyed having you today, and we look forward to doing our next episode soon. Please join us next time as we're joined by another subject matter expert, and we're going to be discussing a good mental model to help us all understand how AI works without the math. We're going to be discussing some of the data, training patterns, predictions, and some real world examples about why AI makes mistakes.